Okay, Bismillahirrahmanirrahim. Let's learn this quotient rule in the differentiation. Okay, so you see that we have started this differentiation uh, from the technique that if we have to find the derivative of the algebraic expressions in their simplest form. So this is nx to the power n minus 1. The second rule is the derivative of ax. Like when you have um, the powers on the whole expressions, then this is going to be n into ax plus b to the power n minus 1 times a. And then in our last lesson, we have learned how to differentiate a product, like where u and v are functions in x. So this is going to be uv dash plus vu dash. Now we are going to move on to the fourth technique, the fourth basic technique of the differentiation, that is called the quotient rule. So this is going to be d by dx of u by v. Okay, so this rule is, this has to be v square. This is vu dash minus uv dash. You have to be very careful with this formula because there is a minus in between over here. When we were practicing this product rule, so there was no need to worry because there was a plus sign. So if someone writes VU dash first and then writes the UV dash, so that makes no difference. But here you have to remember that this is going to be V square in the denominator and then VU dash minus UV dash. So this is all surrounded by the V's. If you just wrote, memorize it, this is all surrounded by the V's. The U's are in between over here. Okay, just remember that. Okay, so now this quotient rule is applied where you have no other option than going into like application of this quotient rule. Because I'm saying, I'm using the words no other option. Sometimes you have, for example, you have an expression which is y is equal to let's say 2 over x plus 1. So there is no need to apply the quotient rule over here because this can be written as 2 into x plus 1 raised to power minus 1. Okay, and then there are the cases like, for example, you have x square minus 1 cube over the square root of 5 minus x cube, let's say. Now some students, they don't like learning so many rules, so what they do, they write it this as x square minus 1 to the power 3 and then this 5 minus x cube to the power minus half, and then rather than taking this as a quotient situation, they apply the product rule onto it. The purpose of learning all these techniques is to save our time, to save, to avoid getting into the hassles or like putting ourselves in trouble. So you must know that what technique has to be applied in what situation. So if you have a quotient over here which cannot be splitted, for example, if you have something like this, x square plus 5 over, let's say, x cube. So this is a situation where you can split them. So you should not be going for the quotient rule. You can, you can write this as 1 over x plus 5 over x cube. So this is easier to differentiate rather to use the quotient rule on all of it. Okay, so the first thing is that you must be clear that in what circumstances you have to be using this quotient rule. Okay, now let's start practicing the questions from this book we have here, the P3 book with us. Okay, so now I'll be starting with the first part of this. Okay, now we have, let me write this as a y, that this color is not so clear. Okay, let me write this as a y equal to 2x plus 3 over x minus 4. So my u is 2x plus 3 and my v is x minus 4. My u dash is going to be 2 and my v dash is going to be 1. So it is good to write this formula again and again. So if you have your y as u over v, so this is v squared vu dash minus uv dash. Therefore, your dy by dx is going to be your v square is this is x minus 4 whole square. And then you have v, which is x minus 4 times the u dash, which is 2 minus you have u v dash. Okay, u is 2x plus 3 and your v dash is 1. So really, since these are really lengthy procedures, lengthy solutions, lengthy working, so you have to be patient. Okay, you have to have control on yourself. There is a big chance of making a silly mistake, making the plus minus mistakes over here. Okay, so try to be cool minded while solving, differentiating these quotients here. So there is no need to expand the denominator. Since x, this remains as x minus 4 whole square. So I can expand this is 2x minus 8. Then I have minus 2x and minus 3. Okay. So we are left with minus 11 over x minus 4 whole square. Can you recheck if there is any mistake over here? Now let's try a bit harder question from here. Uh, First, I need to make some space here. Okay, so I have, let me take a question from here. Maybe, yeah, the H part. This is going to be, I'll write this as y equal to, I'm doing this H part, okay? Y equal to x plus 4 whole square over x square plus 1 cube. Can you please confirm that because I can see this. I think this is cube. Yes. Okay. So we have u equal to x plus 4 whole square and we have v equal to x square plus 1 whole cube. Now, this u dash is going to be 2 into x plus 4 raised to power 1 times 1. So this is going to be this. And this v dash is going to be 3 into x square plus 1 whole square times 2x. So this is 6x into x square plus 1 whole square. So we are ready with the u dash and the v dash. Now we know that this dy by dx is going to be this is v square vu dash minus uv dash. Okay, so this is going to be x square plus 1 whole to the power 6. Okay, and then v is x square plus 1 whole cube and your u dash is 2 into x plus 4 minus u is x plus 4 whole square and your v dash is 6x into x square plus 1 whole square. Okay, you see now your favorite algebra. You have to do a lot of algebraic simplifications here. So I see that I have 2 common, then I have x square plus 1 whole square common. I have x plus 4 as common. Okay, so now what is left here? X square plus 1 from here and we have minus 3x into x plus 4. Yes, so this is left, this 3x into x plus 4 is left from here and I have x square plus 1 whole to the power 6. So you see that this is going to be cancelled by this, and you're left with the power 4. I should change this color. So there is a power 4 left here. Okay. And then, okay. So uh, this is going to be simplified into, that is equal to 2 into x plus 4 into, now this is x square and this is minus 3x squared. So we have minus 2x squared, then we have minus 12x, and we have plus 1. So that is the final answer over x squared plus 1 to the power 4. Okay, let's do apart from question number 6, and we do question number 6 uh, C part. Okay. Okay, let's do this 6C. Okay, this is, and again, I'll put that equal to y. This is going to be 3 minus x squared over under root x squared minus 1. So we have, let me write u over here. U is 3 minus x squared, and v is the square root of x squared minus 1. So u dash is minus 2x, and v dash is 1 over 2. You must be very quick at differentiating this square root thing, okay? 1 over 2 under root this, and you write its derivative at the top here. So your v dash is x over under root x squared minus 1, okay? So we are ready with the v dash and the u dash, okay? So let's write the formula again, that your dy by dx is going to be, this is v squared, this is vu dash minus uv dash. Okay, so this is going to be dy by dx. So when you square this v, the square root will be cancelled, okay? So we have under root x square minus 1 times minus 2x. I can write this minus 2x here, okay? And then minus u is 3 minus x squared into this x over under root x squared minus 1. Okay, you have to take the LCM of this numerator here. Okay, so the LCM over here is going to be under root x square minus 1. So this under root x square minus 1 into this under root x minus square minus 1 will give you minus 2x into x square minus 1. And you have from here minus x into 3 minus x square. Okay, Walid, do you know that if you have A over B divided by C, that actually means there is the C is actually over 1 like this, okay? So this becomes A over B times 1 over C. So you can write it as A over BC. So I will be writing this x square minus 1 as 1 over, this is a very important step. Like again, this is your algebra that really puts you in trouble. So this is minus 2x cube and plus x cube. This is going to be plus x cube minus 2x cube. So this is minus x cube. Minus 2x and, sorry, minus 2x into minus 1 is plus 2x, and this is minus 3x. So we have minus x over, now you can write it as x square minus 1 into this, or you can combine their powers as well. You can write it as x square minus 1 raised to power 3 over 2. You see that your algebra, your differentiation is over at this level. But after that, all of this is the algebra, okay? That you have to simplify through the algebra using your algebraic muscles here. So anyhow, I have given you 3 examples so you can practice this so that you can master this quotient rule. Okay.